Good afternoon, everyone. This is your Master Frank, and I'm here again to teach you physics. And I want you to know that physics is a very, very simple subject. It's what you do every day. You definitely everybody work with physics, but it depends on on your knowledge concerning or how you understand physics. So this afternoon, we want to look at a topic called the circular motion, and as you can see, we have two words joined together that makes up that topic, which is circular and motion. So first thing first, what is motion? Motion is the change in position of a particular body or any body with time. And by now, I suppose you should know that there's a certain thing that causes an object to change its position in a particular period of time, which is motion. There's a certain thing that causes motion, and that thing is called force. All right, so force is an agent that causes motion that results in push or pull of an object. So on a broad base, I'm taking you back to what's your knowledge about motion. I'm taking you back. So on a broad base, motion is categorized into two. It is categorized into kinematic and the dynamic motion. The dynamic motion is the study of force and the object in motion. All right, the force that causes motion and the object in motion. While the kinematic is the study of force that causes motion, force only. All right. So under the dynamic motion, we have this circular motion and all other motion, but this is what we want to talk about. So circular motion is a special curvilinear motion that it's a special type of curvilinear motion in which a body revolves around a cycle about a fixed position. So let's write curvilinear motion. Circular motion is a special type of curvilinear motion. Curvilinear motion in which our body moves round our cycle about a main position. Now let's suppose we have a certain object. Let's call the for example, we are familiar with satellites. Let's suppose we have the moon revolving around the surface of the earth. That an example of that is rotational motion. So we can also categorize that the circular motion. Let's suppose we have an object here, and the object stretched out and continue to move and form a cycle. And let's suppose this is the main position, or you say fixed position, or you say point, whatever it is you call it, around a cycle. Now let's suppose the objects move away from the main position. Let's call the position A to another position. Let's call the position B, at an angle of theta to the mean position or the fixed position. Now let's say the distance moved by the object is x, and we know that a line drawn from the center of a cycle to touch the circumference of a cycle is referred to as the radius of a cycle. All right. Now there are some things that you need to know that are attached to circular motion. But before I let you know about that, circular motion is divided into two. I want you to know that before I move on with this. It's divided into uniform and non-uniform circular motion. So we are going to talk about that later, but I need you to know these things first. So now, if we take a look at the motion exhibited by this object, we discover that the object will move through a distance, let's say s, in a particular period of time, and let's call that time t. All right, the distance moved per the time taken by the object is regarded as what? As linear speed. But in terms of this object, in terms of this object moving in a cycle, you can observe that the object moves around the cycle and form an angle. So the distance moved covered by the object in that particular period of time is referred to as angular speed, not a linear speed. Why? Because the object is revolving around the cycle and forming a certain what? Angle to its main position. So therefore, this distance covered in a particular period of time is referred to as angular speed, not linear what? Not linear speed. So now, therefore, what do angular speed relate? Angular speed relate two things together, which is the angle and the time taken. So therefore, angular speed represented by a Greek letter omega. Angular speed is defined as the angle turn divided by the elapsed time. So angular speed is equals to theta over t. Now, and where your theta is measured in radian. It's measured in what? In radian. And the time is measured in seconds. So therefore, the SI unit of the angular speed is radian per seconds. All right. Now, so where theta is measured in radian and t is measured in seconds. So, what is radian? Let me ask you. Let me ask you, if you know the meaning of radian, you can kindly comment in the comment section. All right. Radian is defined as what? As the angle formed when the what? When the radius of a cycle is equals to the what? To the arc of the cycle. All right. Radian is defined as the angle formed by the arc of a cycle. Arc of a cycle when the angle formed by the arc of a cycle when the radius of a cycle is equal to the length of arc of the cycle. So now let's suppose we have this. Now the only condition where we can have radian is if the radius is equal to the length of what? Of arc. That is, if theta, if r is proportional to s, or if s is proportional to r, that is, the value of this produces this. So both of them are proportional to each other. Now, if we change this to equal sign, we're going to have our radian, which is theta, and the radian theta is going to be r over what? Over s. Or you can say theta is equal to s over r, whichever way. But basically, we are going to go with this. That is, theta is equal to length of arc over what? Over radius. If that is the case, angular speed, do not forget, let's call this equation 1. So from equation 1, where angular speed is theta over t, we can say that angular speed, which is same thing as theta multiplied by 1 over t, is going to be equal to what is theta? Theta is equal to length of arc, or we say the distance moved by the object performing the circular motion, over what? S over r multiplied by what? 1 over t. So the angular speed, we can transfer this to this place. We can have it as this one to be 1 over r multiplied by s multiplied by 1 over t, and the angular speed will be 1 over r multiplied by s over t. This is length of arc over a time taken. If that is the case, we can say that angular speed is equals to 1 over r multiplied by what is distance over time is velocity. All right, velocity. Okay, now so we can say that angular speed is equals to velocity over radius, and then so therefore linear speed or linear speed will be, angular speed multiplied by what? Multiplied by radius.